Okay, we are on. All right, now let's talk about relative speed. I think we've talked about this before, but it's important to understand relative speed specifically. Can anybody tell me, maybe you've read a little bit of the chapter, somebody tell me anything about relative speed? What do we got? Anything? All right. All right, this is relative speed. I'm a bus driver, okay? I'm a bus driver. And you're this is the seating arrangement is a little weird on this bus because I'm the bus driver and I'm driving like this, okay? And you're the passenger, so you're kind of sitting at tables facing me to the side, so it's a little bit weird, do you think? So we're going this way, right? Yes? So we're going this way, and we're going this way, and we're going, let's say, what's a good speed? We're on 10E. What's a good speed? 100? 100K? An hour, is that all right? Are you okay with that? You okay with that? You don't seem very excited. All right, it's a little better, okay. So let's say we're going that way 100 kilometers per hour. Notice I have, that's an arrow, right? Notice two things about that. I have this, which is called what? The what? Magnitude? Remember? Or what else is it called? Yes? It's not working? Dismiss, battery low. That's okay. I have a few minutes and I'll just put my computer out here. The battery's not what it used to be. So what else is this? 100 kilometers per hour. Yes?
Speed.
Speed. Okay, that's the speed, okay? Okay, and the fact that it's going this way indicates what?
But it's not.
That's the direction, isn't it? Is that the direction?
Mm-hmm.
Yes, that's the direction. Okay, so that's the direction. And what should we call that? Anybody know that direction? This is the front of the building. So which way is that? Oh, I have my cell phone. I will look up I'll do a compass thing, okay? So,
Velocity.
what is it?
Velocity.
I can't hear you.
Velocity.
It's velocity, right. It's velocity. So it's going that way, yes? Yes, and it's going that way. Let's see if I can call up my handy dandy. The battery on this cell phone is kaput. Kaput. It's not very good. I have to constantly hook it up to a battery. All right, so let's see what we're doing here. It is going to be, all right, so according to my handy dandy, I got to calibrate it. It's amazing how this stuff works, isn't it? All right, so it's going to be, which way are we going? We're going this way. So that way is approximately northeast. Okay? That's northeast. Okay? That's northeast. The fact that you have a magnitude and direction, the direction is what? What's the direction? Northeast, right? That's the direction. To the right, northeast, correct? All right. So that's the direction. So this whole thing, somebody just said it, is called a velocity. Right, excellent. So the whole thing is called a velocity, correct? Now can I get rid of some of this stuff? It's posterity, it's been filmed, yeah? So I can get rid of all this, okay? I want to get rid of that. I want to get rid of that. And notice one more thing. Notice one more thing. This is an arrow. An arrow. What's that side of the arrow called? Shall I give you a hint? The head. Okay, that's the head. Okay? And this side of the arrow is called the what?
A tail.
That's the tail. Okay? The head and tail. You don't put feathers on an arrow in physics. We don't do feathers, okay? You got that, Rauda? I know you're very excited about that, but you can't put feathers. We don't have feathers in physics, okay? All right, good. Unless you're in a vacuum and you're dropping a penny at the same time. Marin.
I thought it levels the arrow, keeps it straight.
Yes, it does. If this were that kind of arrow, yes, it maintains the integrity of the flights. Absolutely. Yeah, true. But this isn't archery. This is just an arrow that indicates what? What's the arrow indicate? The presence of a vector. If you don't have you got to have the head on it. Okay? If you don't have the head on it, it's a chicken without a head. Okay? You want to have a pet chicken without a head? Does that be a little weird? You have a pet chicken without a head? It's a little weird, Rauda. Okay? Is that like a UAE thing or no? But you'd like to have one. Okay, excellent. Okay, so you got the picture? Vector, magnitude, direction. You with me? Speed. Laura, you okay? You look very excited. Okay, excellent. Right, now. So let's say that Jamie gets up. We're going 100 kilometers per hour this way, correct? And she gets up and she runs. I don't want you to do it. We're just going to pretend you're going to do it. Okay. She's going to run 10 kilometers per hour this way. Okay? She's going to run, that's too big of an arrow. Okay, she's going to run 10 kilometers per hour that way. Now, let me ask you a question. What is Jamie's speed? What is Jamie's speed? What is Jamie's speed relative to the bus? What's Jamie's speed relative to the bus? Relative to the bus. All right, forget that question for a minute. Vivian's looking at me like I'm crazy. Okay, trust me, it's not me. No, I'm teasing. Okay, what is the speed of the bus relative to the road? Vivian. It's as easy as it sounds. It's not a trick question. What is the speed of the bus relative to the ground? No, what is the speed? What's the speed? 100 kilometers per hour, right? Right? If you're driving in a car going 100 kilometers per hour, what's your speed relative to the road? If the speed is really 60 and you're going 100, the cop's going to give you a ticket for going over the speed limit relative to the road, right? Okay, so relative to the road, the bus is going 100 kilometers per hour. Jamie gets up out of her seat and runs that way 10 kilometers per hour. What is Jamie's speed relative to the bus? Anybody? Go ahead, Nora. What do you want to say? What is it? 10 kilometers per hour. That's right. Very good. So relative to the bus, it's 10 kilometers per hour. That's the speed. What's the vector? What's the vector? Go ahead. Go ahead. What's the vector? First down. That's it. What's the vector? The vector is that way, right? Right? That way. So the vector is like that. So that's the speed and that's the vector, correct? Yes? Okay, that's the speed, that's the direction, the vector's that way. Clear? Okay. Now, what's Jamie's speed relative to the road? What's Jamie's speed relative to the road? Nora? No, that's relative to the bus. 10 kilometers per hour relative to the bus. Yes, Julie? 0. So if the bus all of a sudden disappeared, she'd be standing still. Is that right? Remember, the bus is going that way, 100 kilometers per hour. Jamie's going that way, 10 kilometers per hour. Anybody? Jamie? No? Shall we indicate direction like this? This might be easier, okay? Let's say that this is going to be plus 100 kilometers per hour. Isn't that direction and speed? Plus 100 kilometers per hour? Isn't that magnitude and direction? Isn't it? Isn't this a vector? Isn't it? Okay. So she's running that way. So what would her vector be? What would her vector be? Yes? Negative 10. Okay, good. Now, can you do it now? What is Jamie's speed relative to the road? She's running that way, but isn't she going that way? Isn't she? Isn't she?
Yeah.
Look, the bus is going 100 kilometers down the road, right? But isn't she running in that direction? But isn't she running in that direction? Isn't she actually traveling in that direction? Yeah, she is. So what? What do we do? Yes.
We add negative 10 kilometers per hour and positive 100 kilometers.
That's right. You're going to add the vectors. You're going to add this vector with this vector. Remember we did adding of integers, remember? Mm-hmm. So what is positive 100 plus a negative 10? What is that? You need a calculator?
Positive 90.
No, not 90.
Positive 90.
Positive 90. Okay? Equals positive 90. So what's the direction? That's the magnitude is 90. What's the direction? What's the direction? Positive, right? Now, interpret, yes, Nora, that's correct. You're pretty good at this, Nora. Now, interpret that 90 in terms of arrows. What would it be? Nora, you just answered the question. Interpret this to the right, this way. So her answer would be 90. Right? So in other words, let's say that's 100. Right? And let's say, so this has to be really drawn to scale. I mean, it could be, right? Yes? So we'll say that it's going to be like, is that about 1/10 of that? More or less? Right? Wrong way. So, what is this plus this? Isn't it going to be this? Or plus 90. Okay? Right? Yes? Do you understand? Let's see if we can get this. You ready? You ready? Write this down. I'm going to say this. I want you to look at 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 this video. You ready? What have we learned today? Okay. What have we learned today? This is based, I'm going to say things that weren't necessarily gone over today, but gone over in past days. Okay? Yes? Is that all right? Okay. Velocity is a vector made of magnitude and direction. Velocity is a vector made of magnitude and direction. An example. I'll give you an example. An arrow going this way at 100 kilometers per hour. That's a vector. Clear? Magnitude, right? Magnitude and direction. Clear? Yes? You can represent direction in a variety of different ways. You can use an arrow. Clear? You can use positive or negative. You could use compass direction. Northwest, northeast, north, south, east, west. Or you could use what? Something called the unit circle, degrees. You've heard of degrees? 90 degrees, you know what that is, right? Yes? Okay. What we're going to do is this. We're going to work with a unit circle when we do this in the next chapter. And we're going to say, here's a circle, right? And this is going to be 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. You get that? Yes? What would this angle be? What would that angle be? Halfway between 0 and 90. What would it be? What is it? 45. Be 45. How about halfway between 90 and 180? What would that be? What would it be? 90? No. Halfway between 90 and 180. What would it be? 145? No. Well, what number is halfway between 90 and 180? Add 40, isn't it 45 degrees away from 90? So what's 90 and 45? 135, that's right. So you can represent a vector with many kinds of direction. With degrees, an arrow, degrees, plus or minus, north, what was that, northwest? Is that what I said, or northeast? Whatever I said, okay. Northeast, north, south, east, west. Clear? You get it? Understood? You sure? Okay. Vectors can be added. Vectors can be added. Can speed be added? No. It has to be a vector. In other words, it has to have direction. It has to have direction. Plus, minus, plus, minus. It has to have direction for them to be added. Clear? They have to be added. They have to be, right? Yes? You get it? Okay. So that's it. Relative speed. What is Vivian's speed? What is Vivian's velocity relative to the road? She's running that way, but she's actually moving that way. And what did we say it was? Plus 90 kilometers per hour that way, correct? Yes? You see that? Isn't that a little weird? Yes? Okay. Now, what is that called? What did we just do? Relative speed, relative velocity, relative speed. You want to see something really cool? If you next time you're on, anybody been on 10E over the weekend? Does anybody spend any time on 10E, 11E, going to Dubai, whatever? Okay, or just on a road? Anybody been in a car all weekend? Okay. When you're going on a road, let's say you're going 60 kilometers per hour or 100 kilometers per hour, whatever the case may be, assume that the car that's coming at you, right, is going at maybe your speed or somewhere around your speed, right? Yes? So watch your speed. Watch how things that are stationary, like we're driving in a car and we see a building up ahead. We're slowly approaching it, right? We're approaching it at a certain speed, correct? And you can get used to that. But what happens when a car's coming at us? Watch that car and see how quickly they come at you. Because if you're going 100 kilometers per hour and the oncoming car is going 100 kilometers per hour, how fast is the car approaching you? 200 kilometers per hour. So that's what it would look like. If a car's going 200 kilometers per hour, that's what it would look like. When the car passes you, how fast are they going away from you? Yeah, 200 kilometers per hour. Yes? You get it? You understand?
Yes.
Get it? Weird, huh? Isn't that weird? Kind of goes against all the things we just learned, but it's pretty cool to watch. It's very cool to watch. Okay? Should we stop this? We'll call this relative speed. Is that okay? Yes? All right.